Next up, we'll take a look at the muscles surrounding the elbow. Now, the elbow can only do two things. It can flex and it could extend. And we'll start off with the muscles of flexion, very popular muscles known as the biceps. We have, of course, two heads of the biceps. We have the short head, which is more medial, the long head, which is more lateral. You can think of long, lateral, both begin with L. And then, if we can remove, let's hide the pec and hide at least the anterior or the entire deltoid, hide the platysma as well, we can see that the biceps actually cross two joints. We know that they're going to cross over the elbow, causing elbow flexion to occur when the bicep is shortened. But we also notice that the biceps attach on not the proximal humerus, but on the scapula itself. The long head actually is attaching just above the glenoid fossa, while the short head is attaching at this coracoid process. So because of this, we can actually say that the bicep assists in shoulder flexion, going in this realm right here in the sagittal plane, and we can say that at least the long head of the biceps assists in shoulder abduction when we're pulling our arms out to the side, just based on its orientation being more laterally located. It will do that as well. However, it does have another very important function, and that is supination. Okay, so if we're in this position right here, our hand is prone, and if we think about this in terms of exercise grips, right now this would be what we call a reverse grip, where you would have a prone grip on a bar or a dumbbell or a cable or band, whatever we're using. We would be in a prone position, a pronated position. All right. Now, going from that position to this position, going from prone to supine, or pronated to supinated, the bicep is recruited. And the bicep is a major mover, the major mover in supination, going from this to this. So what does that mean? How does that relate to, say, biceps exercises? Well, if we have this position right here, an overhand grip or a pronated grip on a bar or a dumbbell, and we're doing curls, those are called reverse curls. Now the problem with that is that the bicep is lengthened even when you're in full flexion. It's lengthened so much that another muscle has to take over, and that muscle is a muscle that's actually located underneath the bicep. See the space here? There's actually a muscle that lives there. It's called the brachialis. Okay, so the brachialis is going to be targeted in this pronated grip as you're doing curls. All right, so then how about a neutral grip? Well, now the biceps can be engaged a little bit more, but we're going to say that the prime mover, or a prime mover, is actually going to be a muscle that travels from the brachial region, which is the upper arm region, down to the radial region, which is, of course, the thumb side. Bone is the radius. This is the radial region, the thumb side, forearm region. And this muscle that crosses from brachial to radial is just simply called the brachioradialis, the handshake muscle. So if you're shaking somebody's hand, you're not looking them straight in the eye like you should be, you're staring down, you're looking at the brachioradialis. So in this neutral grip, where the palms are facing each other, you can do hammer curls, for example, you see the brachioradialis being recruited greatly. Okay, so that's the biceps. Let's turn it around and take a look at the triceps. Now, the triceps are going to be responsible for elbow extension, and we name different triceps exercises really based on where the humerus is located. In this case, we have a neutral location, an extended, you can say, humerus. It's locked in this position, and if we were in this position and doing tricep pushdowns, for example, then we can call tricep pushdowns because the humerus is locked in this position. Now, the triceps course, do elbow extension. And notice that they are attached to the ulna down here. All of them merge and form a tendon of the triceps. But notice where the attachment sites are. We have the long head, we have a lateral head, and then we have a medial head underneath. The long head actually crosses two joints. It crosses, of course, the elbow, but it also crosses the shoulder joint as well, as it attaches to the scapula. So, when we have a tricep exercise where the your elbow is beyond your spine. In fact, you're hyperextended, your shoulder is hyperextended, say in a tricep kickback. That means that the long head of the tricep, the most medial one here, the long head of the tricep is actually shortened because we know that it's shortened at the shoulder and it can also be shortened, of course, at the elbow. But a muscle that's already shortened at one joint cannot be truly a prime mover in the second joint. So doing tricep kickbacks, that's really going to target more of the lateral and medial or middle head of the triceps. However, what if we have this shoulder oriented in, let's go back up here and go into shoulder flexion. What if this shoulder is flexed? If this shoulder is in peak flexion, I'll pause it when we get there, peak flexion, wouldn't this mean that that long head of the triceps, not shown here, but the long head of the triceps would be lengthened at this point? And so if you're doing an exercise where the shoulder is in flexion, the humerus is locked in flexion. Now just picture this elbow flexing and extending from this locked humerus position, say in a tricep extension exercise, or in what they call a skull crusher exercise. You can do a push through underneath the bar or using a TRX or exercises of that sort. Anytime you're locked up in this position, then you really are going to be targeting that lateral head of the triceps because it is lengthened at the shoulder, and it's also going to be able to be lengthened and shortened at the elbow. But because it's lengthened at the shoulder, it can truly be a nice prime mover. So talk about bodybuilders. They will strategically orient their bodies in order to target specific heads of the biceps and triceps. From a functional standpoint, does it really matter that much? Probably not that much, but it's covered.